Hello, and thank you for your interest in our paper on crowdsourcing design guidance for contextual adaptation of text content in augmented reality. Augmented reality is still at a relatively immature stage, and there is a lack of design guidance available to developers to help them build compelling applications. Crowdsourcing presents an attractive strategy for eliciting design guidance, given the ability it provides to reach a diverse group of users in diverse physical settings. The benefits and opportunities afforded by crowdsourcing have been demonstrated before, but there has been limited exploration of the role that crowdworkers' own physical environment can play in studies relevant to AR, and in particular the problem of adapting content to physical context. To make our investigation concrete, we focused on the problem of adapting text content given the physical context. This problem has been widely explored in lab-based studies, giving us a useful reference against which we can compare our findings from the crowdsourced approach. Interestingly, this study here by Debonardis et al. Makes the general purpose suggestion to use white text on a blue billboard, having found this worked well across different device and background types in their lab-based study. To accelerate the establishment of design guidance and complement lab-based studies, we present a method for crowdsourcing AR design guidance. This is delivered by a privacy-conscious web application delivering a low-fidelity, mobile-based AR experience. To demonstrate this approach, we elicit design guidance relevant to the contextual adaptation of text content. Crowdworkers perform the context capture and appearance feedback task in their own physical context. The method has 4 key stages, which I will go through now. The goal is to collect user feedback on a diverse range of background contexts. Therefore, we introduced an AR search task that prompts crowdworkers to capture different views of their local environment. This was achieved by requiring participants to look around and find a virtual bird in their local space. When participants located the bird, they would press the capture button, as if they were taking a photo of the bird. A text panel would also appear, providing some detail on the bird. In the paper, we describe 2 different experiments examining different aspects of text content appearance. Experiment 1 focused on panel coloration. Once the image was captured, participants were instructed to adjust the appearance of the text panel with the instruction to maximize visibility and readability of the text. Experiment 2 focused on panel placement. After capturing the image, participants were instructed to choose where the text panel should be placed. They could do this by tapping on the image. Given potential privacy concerns introduced by capturing images of crowdworkers' own physical personal environments, we developed a simple image review protocol. The web application design was such that captured images remained on the client side until they were explicitly approved by participants, at which time they were transferred to the server. If participants wished, they could also add pixelation to the image to obfuscate any sensitive or personal details shown. Participants were always free to reject sharing an image without any penalty. As mentioned, we employed this method in 2 separate experiments. 200 crowdworkers participated in each experiment, with each worker performing the search, capture, and appearance refinement task 5 times. We found that the method delivered high levels of engagement and image approval rates exceeded 99% in both experiments. The majority of images were shared with no pixelation, but the ability to apply pixelation was widely used and appreciated by participants, as reported in a post-task questionnaire. We were able to find clear and informative patterns in the context-dependent appearance feedback captured from participants. This figure shows the distribution of panel color choices grouped based on the dominant background color of the physical context. It is interesting to note a clear preference for blue billboards with white text, a result showing good consistency with Debonardis et al. We also found users' choice of text color demonstrated good agreement with the established recommendations on the choice of text color given the perceived brightness of the billboard color. Finally, we used the collected design guidance to derive a preference model for determining appropriate appearance and placement of text content given the background context. This was deployed as a demonstration on the Microsoft HoloLens, as shown in this video. To conclude, our paper introduces a privacy-conscious method for conducting AR experiments via crowdsourcing to complement lab-based studies. We show that the method is effective and delivers useful findings, and we expect that it can be applied to a wide range of emerging AR design problems.